Hi, good morning everybody. Thank you for joining. My name is Neil March. I'm an ex-product specialist for Beckhoff Automation for a new product that we've launched pretty much at the beginning of this year, and it lends itself to getting those steps to actually decentralising and removing cabinets within automation. I suppose the first question to start with is, why remove a cabinet? Cabinets have been around for a long time. They serve a purpose. They are the central point of any machine. A machine has functions that it has to carry out, and the controls to carry out those functions contained within a cabinet. The cabinet has always been a functional point, and we've got used to it. It's part of a machine. We accept it. But are there alternatives? That's the question. So this is what we're hoping to show you today. I won't call it a typical machine, it's a bit clean for that, but generally, yes, it's a machine that has end functions. It has a lot of cable connecting it back to the central point. The central point, obviously, is the cabinet. And the cabinet on the left-hand side with glazed doors, which I haven't seen for a while, but that is always acceptable. Whatever else the machine is doing, we accept the fact that there has to be a point where a cabinet controls everything. So where are we in cabinets at the moment? Well, the first thing is, a cabinet in itself is a component. It's not a finished product. You have to do things to that cabinet in order to make it a finished product. You have to do a lot of design work, particularly if you're working from a clean sheet. There's a considerable amount of work to do in them to bring the design of the cabinet together. There's a procurement process to bring in the products that are designed to go in the cabinet. That in itself can run into hundreds, maybe even in some cases thousands of components. And then you've got to build and test the product. That involves skilled staff and equipment. Equipment, CNCs, drilling, tapping, cutting, all of the processes that are needed for this cabinet to come together. And then you have individual terminations. All the wires have to be individually crimped, terminated, indented, and then finished off into the products that are contained within. And of course, all of this is not error-free. There are occasions when things go wrong. There's also installation, which has to carry out at least once with the machine in this first instance, and then secondly, when it gets installed on site. And then there's of course the multitude of cables and other equipment that needs testing to make it work. So why remove a cabinet? Well, the consideration will always be that there is a saving to be had. There are reasons that you want to make that cabinet disappear. Labour is one. If it's a high labour product, then labour is still a major part when it comes to making machines. There's the hardware, reduction in hardware, procurement, reduction in component counts. Maintenance is a very big one. Diagnostics and inflexibility. Machines nowadays want to change and become, they want to morph into something else very quickly at a press of a button. And then one big one is real estate. Underneath that cabinet that has to go with that machine is the real estate that it sits on. Now, that doesn't cost too much money during the manufacture process, but it's an ongoing cost for the end user who has to continually pay that money for that cabinet to sit on the shop floor. And then, of course, there's transportation. It's 20%, 10% more to transport the machine from point A to point B. So, what are the requirements to move away from a cabinet? Well, first of all, you've got a housing that you've got to consider, that anything, once you move that cabinet, you have then to replace the function of that housing. There are I/O components, functional safety as well, that's contained within there, motion, and the power supplies. The generation of 48 and 24 volt all need generating, as well as protection for those for the DC voltage and AC voltages as well. There's also the logic, the control element that's contained within. Now you've got to consider how and where that's going to be located. There's a higher voltage links, particularly with motion. You're dealing with 600 volts DC that you have to deal with and distribute. Speed controllers could be asynchronous motors. and peripheral connections. All those cables and all those connections come all the way back for something. If I'd have stopped it there, then we would have probably designed a cabinet to actually do what we needed to do. But instead, we took it further. Beckhoff have taken it further into this system. And we then had our own requirements. And plug and play, ease to assemble was one area. It needed to conform so we could deal with Canadian standards, UL, European regulations. And it has to be modular, easy reconfiguration. Scalable, make it larger, make it smaller, deal with the larger or smaller machines, and also to distribute power and data, both power and data. We don't consider them as separate items to actually deal with. EtherCAT connectivity goes without saying, we are Beckhoff, so we will always have EtherCAT as a connectivity, and a tool-free construction. That is in the assembly. Industrial protective housing, and of course proven technology. Beckhoff have proven technology over many years. On-site diagnostics. Suddenly you've lost a cabinet door that you would break open and switch the isolator on with a pair of pliers, get in there with a multimeter. That's no longer the case. And also the big one, of course, try and keep it cost effective. So we have a product, there is a product, not just ours, there are other products out there that actually cater to be able to do this. But it's worth saying at this stage is that the biggest question we ever get is usually how much would it cost to replace that cabinet? And the thing you get with this system is that you cannot and you will not get to a point where this product will in fact push that cabinet out of the way and just replace it. It's not that simple. Cabinets are much more complex, and you have to then deal with everything else that the cabinet also deals with, which is remote. Just looking a bit further down into the construction of it, I'm not going to spend too much time on this, but there are different layers of rows that we have on there. 1, 2 and 3 rows, and they all relate to different powers that we can deal with. The widest we can go to is a 32 slot as a base unit, and that 32 slot is about 1.5 meters wide. It's a very big, large lump of aluminium, but it means we can cater in there for all the voltages. There are a multitude of modules that sit on top. They simply plug onto the top and are simply screwed in using the torque screwdriver. The next slide will show how they connect together. But there are different modules of everything from relays, contactors, reversing contactors, AC motors, DC motors, servo motors, and standard relay modules as well. A whole multitude of I/O and couplers, even down to I/O link. Construction itself contains several bus bars, shipping around the EtherCAT communication data, moving the 24, 48 volt data power supplies as well as the AC and high DC voltages. That's all contained within. The modules merely just sit on top. The housing, aluminium, zinc, IP67, it's passivated, protected, and it can work up to 0 to 50 degrees. Passive cooling, so there's no forced cooling, but also contained within there is environmental monitoring. This monitors the temperature of the unit itself, as well as shock, vibration and dew point. Connecting this beyond that point onto the machine it uses many different layers to actually achieve that. EtherCAT has been around for many years. That quickly morphed itself into what we see there, which is 2 twisted pair, which also carry 2 times 3 24 volt 3 amp supplies as well. And it's along those lines that we continue to develop this hybrid connected cables. We now have a multitude of connected cables on there. So at the top you see we have the M8 connection, which is 2 times 24 volt DC, each with 3 amp. That's what we've just seen. But around it now we have further cables. These are larger and they are hybrid, so they contain effectively 2 cables. We're moving higher up onto the AC and larger DC voltages. So not only can you actually take the whole unit and have it as a central point, you can now distribute that central point further beyond where it started. The connection inside is in fact the EtherCAT P. So the connectivity, being able to move that around the machine, is still there within the cable along with the power, and the power is a requirement for making obviously the products to move. But it's not just those hybrid cables, there is a multitude of cables. So the whole system effectively starts from a base plate with modules that are screwed on, allowing you to then move that out with connections that are pre-made cables, allow you just to use bayonet connections or screw types. I didn't spend too much time putting together information about the architecture here, because the architecture is driven by how you want to make a machine work, and therefore that determines how you want to distribute this kind of product and the communication that it can enable you to do. So either way, there is many different ways to move this around. You can stay with the standard where you have just remote motors back to a control center. In this case, you've got then remote motors where you have a remote DC link created for the motors, or you can move on to a secondary module. You can actually step them down, or indeed you have at the top right our IP67 or other IP67 EtherCAT boxes. So in order to achieve what you need with the MX system, you really need to kind of encompass everything else that's going on with that machine. Second biggest question, third-party products. Obviously, we are not possible to produce every single product that will go inside a cabinet. We cater for it in this way. First thing is there is a blank module which allows you to be able to affix a particular item within there. That can be that will provide 24 volts as well as additional digital I/O to go within there, and allow you then to come out with a cable to make that connection. It's very hard to produce anything other than this because we don't know what we'd actually want to actually put within that box. But beyond this, there's also the EtherCAT Technology Group. The connection between all of our products and all of the information here is using EtherCAT as its communication layer. And there are now currently over 8,000 members of EtherCAT, which means there's probably 80–90% of those producing products for use on EtherCAT. So this enables this kind of system to have a multitude of connectivity. The last thing, of course, if in doubt, you can use it into a KL. Use a Rittal KL box or something to put in any unique product that you might have. There are ways to get connected to EtherCAT. So what tools have we got for you? Not screwdrivers, I'm not giving them away. But Torque 25 screwdriver is the only screwdriver that's required to actually assemble an MX system. And it's put together by taking the base plate and attaching 4 or 8 simple screws onto that base plate. You can't go wrong. It's keyed so you can't put the wrong thing in the wrong place. What we also have for you is a configurator. Now at the moment I'm beta tester for one of these, but it's still being tested. Pretty much every single day that we start this up, it does updates. It's constantly evolving. It's becoming a very powerful tool for us. There will be a customer variant. However, there's no timescale for when that will be. And it's a platform that allows us to plan the MX system. You configure in a base plate, you then configure the products you're putting on there, just using drag and drop. One of the greatest parts of this, because of the multitude of cables, it allows you to connect and select the cables that you want to go on there between point A and point B. But it also allows you to select external products, motors, sensors, etc., that you want to connect to this. It allows you to select them and you can bring it all together. So now we've gone from the base plate with the plug-in modules to the cables, and now we've arrived at the far end where we've now got the literal peripheral I/O, and that's pretty much as far as we can go because anything beyond there is determined by the product that you're actually plugging on. Once you've created a configuration, it checks it. It makes sure that you have everything correct. You can see on here there's an orange box around the main switch. because there's an issue with that, and it will help you to get to a point where this is deemed to be a correct configuration, and that can be exported. You can get it out as a BOM in Excel. It gives you a HTML graphic representation of what you've got there. And with all the cabling that you've done there, saying this cable goes from input 1 to this sensor ABC, that then is available as a cable listing. So you actually have a full cable schedule, enabling you to be able to connect everything together. ePlan interface is also planned along with the rest of our products which are available on ePlan, and also direct connection to our automation software. So TwinCat Automation is our automation software, and this will allow a direct interface both ways. So it will actually allow connection into TwinCat by exporting and back again. That's actively being worked on. Also to that, we have diagnostic tools. This is basically a mobile phone, and it's an app that runs on a mobile phone, and it connects and talks to the actual EtherCAT on the backplane via Bluetooth. And that Bluetooth itself on the EtherCAT backplane is like a node that talks to the PC. So for IT people, the app does not connect to the automation. The app connects to the actual EtherCAT, which connects to the automation. So now you've not got that multimeter inside that cabinet. This is the alternative. You look on the front of these units, there's a white square that you'll see. It's a barcode. You scan that with your phone, and then you can see what's going on with regard to the I/O. You can scope it, and you can also then look at the current ratings, etc., of what's being drawn. I dare say it's going to be free. So this is where we started. And this is kind of how you can end up. So moving that cabinet over on the left and reducing the cable, taking it through a distribution points, and either moving multitude of different MX systems around the machine, or indeed using further IP rated IOs to get that connectivity going. Cost. There's always that question. We're not going to say that it saves you money as against the cabinet. As Beckhoff, we build thousands of cabinets in our German head office, so we are fully aware of the cost and what it involves in building cabinets. However, what we have is a system that we know is compatible and is priced in such a way that it is a serious contender for hardware built man-made cabinets. So for this point of view, we're going to kind of say that we expect it to be the same like for like. We don't want people pay for their cabinets. So we come down to really the reason why you would want to get rid of the cabinets. There's the obvious at the top, above the water, everything you can see. Does it cost more than the cabinet? Does it not? Beneath the waves, that's when you start to see everything else. What you don't kind of generally take into consideration, the soft touches, how much it costs for shipping because you're shipping less now, how much money you're saving because it's less space and of course shorter cables. So there's many other areas to take into consideration. The main point being is that you don't kind of approach this as a product that is just going to replace that cabinet. It's just never going to work. You have to approach that this is part of a system that will enable you to remove that cabinet when you address the whole machine. So is it possible? Yes. I can say yes because I've seen it and it's been done. It's very easy. It's not a one-for-one replacement. As I've said, cabinets are around, they're good, they serve their purpose, but it's not just one-for-one change. You have to address the other aspects of the system, its cabling and hardware beyond the cabinet. And the other thing is engagement. It's so often we just get asked, how much is it to replace this cabinet? If that's the question, then that's not really, it's not really engagement. You need to engage truly whether you're going to adopt this kind of a product going forward. How am I for time? Thank you very much. There we go. Spot on. So thank you very much.